Hello everyone, welcome to screencast ID SC10162. In our screencast SC10220, we demonstrated how to configure accelerated multicast. In today's screencast, we will show you how to troubleshoot that feature. So let's get started. The lab topology consists of an AP7131N, which is managed by a RF switch. I also have a video server which would be streaming the multicast video. The entire network is a flat VLAN, which is VLAN 1. We will be creating a wireless LAN which is going to be locally bridged, and hence the AP would directly communicate with the video server. The first step in our troubleshooting process is to log into the RFS switch and AP and gather some statistics. So let's do that. I'm in my RFS switch. Let's do a show wireless client first. I do have a computer which is connected to this particular AP on its radio 1, and it's data ready. It's probably passing some traffic. Let's do a show wireless AP, and as you can see there are two APs. So this particular client is on this AP right here, and you can pretty much see there's only one client here. Our next step is to see if there are any multicast streams on this AP. So let's do a show wireless radio detail, and this will show you the detail on all the radios of the access points that are adopted on this RFS switch. Now, as seen here, we do have the number of multicast streams set to 1, and we have the IP address as 224.0.0.11, and there's one stream right now. This tells us that the AP has detected the multicast stream, and it is converting it to unicast at this point. If you go down and look at the other radio, it says no multicast streams, and the number of multicast streams is also pretty much blank. So this radio is not converting any unicast streams, and obviously because we have no clients connected. So our first step of troubleshooting is to see whether the AP has even detected the multicast stream. So this is very, very important. Once we are past this step, we probably need to gather some more statistics. There is a command called more system proc data plane wireless MCTUC, which stands for multicast to unicast conversion, and then there is a radio MC. If this returns blank, it means that there is no conversion happening. But you got to realize that we have given this command on the 4000. And that's not where the conversion is happening. The conversion is happening on the AP level. So we need to get details from that particular RF domain on which that AP is. So let's do remote debug, more RF domain. Our RF domain name is default, so we use default, and then do a path to system proc data plane wireless MCTUC. So now if you notice, for this particular AP on radio 1, there is some statistics that is being gathered. So if you run into issues, these are some statistics that you should mail back to us so that our engineering team can look at it. If you look at this particular AP, there are no statistics. Or for this RFS 4000, there are no statistics. The reason is there is no conversion happening on these devices at this point. Again, what we did is we did a remote debug command, and we tried to get our statistics for all the devices that are in the default RF domain. In our setup here, we have this AP, and this RFS in the same RF domain. That's why we see statistics coming in from all three of them together. Again, you can give the other command, which is the MC table. And again, you can see here, this AP has some statistics that we're gathering. For this AP, there are no statistics since there is no multimedia. And for this RFS, again, there are no statistics. The next step in our troubleshooting process is to capture some packets on the wired as well as the wireless side. There are two ways we can go with this. One is by having a dedicated sniffer like OmniPeak or Wireshark running on a laptop. The other is using the packet capture capability built into the RFS switches as well as the APs. So let's first look at our packet captures on the RFS switch. So there's a command called service pickety cap on bridge. On bridge would mean any packet that the RFS receives. And I'm going to filter on the destination port as 1, 2, 3, 4, since that is our multicast stream. As you can see, there are a bunch of multicast packets going. 192.168.1.247 is my video server, and 224.0.0.11 is basically our multicast IP address. Now, since the RFS switch, the video server as well as the AP are on the same VLAN, we are seeing these packets here. But I'm really not interested in what the RFS is seeing. I'm more interested in what the AP is seeing, since this is all local bridging. That's where the remote debug command comes handy. We can do the remote debug live pickety cap, specify the RF domain, and then our RF domain is default. I'm interested in radio 1 capture, and I can then filter on destination port 1, 2, 3, 4. As you can see, the AP is receiving packets. It is a UDP packet. 192.168.1.247 is a source of the source IP, which is the video server, and that is the IP address of our multicast stream. So this kind of tells you that the AP is receiving those packets. Let's log into the AP and see what we can get. So let's do a show wireless AP. This is our AP that we're interested in. That's where we have one client connected to. So there is a nifty way to connect to the AP. All you do is type in connect and then the AP name. In this case, it's AP 731 Charlie 78 Bravo Echo 8. And we log in with the same credentials as admin and symbol. And we are now in the AP. Let's first see what packets the AP is seeing on the wired side. So let's do a service pickety cap on bridge. I'm going to put verbose, which would expand the packets. I would put, let's just capture only 2 packets, so let's just capture 1 packet for now. And let's filter with destination port 1, 2, 3, 4, since that is our multicast stream. As you can see, this is an 802.3 packet, so it's an Ethernet frame. It has this source MAC address, which I believe is my video server. 01005 Echo. This is a multicast MAC address. So this is a packet that is coming from the wired video server, and it is coming directed towards a multicast address of 01005 Echo. Again, the IP address is 224.0.0.11. That is our destination IP. So a multicast packet surely is hitting the AP. Now let's see if the AP is really converting this on the air. So instead of doing the bridge, I'm going to change that to capturing packets at radio 1. Radio 1 is the radio of this AP. As you can see, this is an 8211 packet. It is a QoS data frame. The source MAC is identical to what we had here. But look at the destination MAC address. The destination MAC address is most likely the MAC address of our client. It has been the multicast address 01005 Echo has been replaced by this. If there were multiple clients, you would have seen this same packet with a different destination MAC address. So this kind of tells us that the AP is converting this to a unicast packet, and we will look at more details on what the data rate is and some more information. Show wireless client. So as you can see, 002608 is the MAC address of the wireless client, and that matches what we have here. So the AP is most certainly converting this to unicast. Let's analyze a wireless trace that I have captured using Wireshark. This trace was captured before the Accellerated multicast feature was enabled. Now, if you remember from our screencast SC10220, we mentioned some things that the 802.11 spec mandates in regards to transmission of multicast packets. So the first thing is the detune period. Before we start, let's just filter out packets from this one AP. Just going to highlight this, apply my filter. DTIM period that we have configured on our device, the RFS 4000 right now, is set to 2. And if you remember from our previous screencast, the multicast packets are transmitted at the end of the DTIM period. So let's look at this beacon, because we can see a bunch of multicast packets being transmitted after this beacon. So this should be the DTIM count as 0. So scrolling down, we can see that the DTIM period has been set to 2, and the DTIM count here is 0. If we go to the previous beacon, it was DTIM count 1. So packets are not transmitted, multicast packets are not transmitted unless and until the beacon count hits 0. The next thing to notice is our data rate. These UDP packets, which are our multicast packets, are going at 11 megabits per second. If you go back to our beacon and we look at what are the data rates specified, we have 1, 2, 5.5, and 11 as basic. And we are following the spec where we send the multicast packet at one of the basic rates, in this case 11. Hence, all our packets are going at 11 Mbps. Let's analyze our multicast frame. As mentioned, it's going at 11 Mbps. If we dig a bit more deeper to see the IP and MAC addresses associated with this frame, you can see the destination address is 01005 echo, and this is the multicast address. This packet or this frame is not directed to any particular client. It's basically directed to multiple clients. The destination IP address is 224.0.0.11, and the destination port is 1234. This is something that I have set on my wired video server, and that's what it is streaming. Next, we are going to be analyzing our unicast trace, wireless trace, and you will notice that it won't have 01005 echo. This MAC address will be replaced by the MAC address of our client. Let's look at a trace that was captured after the accelerated multicast feature was enabled. The first thing that stands out here is the packets are delivered as soon as they arrive. As you can see, it's not delivered after every 2 beacons, since the DTIM period is set to 2. They are essentially sent as they arrive. The next thing to notice is the data rate of this packet. It's going at 54 megabit data rates. I've set my rates to be 11G, and the packets are going at the highest data rate. Let's dig deeper into this packet. The destination address of this packet is now the MAC address of the Intel or the Apple client that I have in my network. If you remember from our previous trace, this was 01005 echo, which was the multicast address, but now it is a unicast address, and it has been directed towards that client. The destination IP is still the same. The destination port number is still the same. The next thing to notice is this packet is actually being acknowledged. If I clear my filter here, you can notice that the data packet that comes in, which is directed to the Apple client, is being acknowledged by the client itself, and thus this is now reliable. So every packet is succeeded by an ACK frame. This brings us to the end of our troubleshooting session. Thank you for watching.